For any given set of n variables in permutation, when considering reflections and rotations as being arbitrary, all possible permutations are occupied at any given time. Moving any individual variable will simply reverse the order. So 1, 2, 3, 3, 2, 1. No matter what you do, that's the only change that it can generate. With 4, you notice how it's a lot harder to cover these bases, but whenever you do consider that, there's only 3 possible permutations. One where an individual variable is displaced by 1 space or 2 spaces from its respective position, and if it's not displaced, your order is in chronological sequence, so 1, 2, 3, 4. For example, 4, if it was between the 1 and the 2, you would be in the base set that forms the pentagram, and if it was between the 1 and the 3, you're in the base set that forms the pentagon. The only issue is whenever the 4 is between the 2 and the 3, for this example, in which case no placement of the 5th variable will create a solution set. This can simply be resolved by moving any piece anywhere. Whenever you move up to 5 variables, you notice how when you're in chronological order you get that pentagon that I referenced, whereas whenever you're in this permutation, it would be the pentagram. Each permutation with 5 variables, whenever considering rotations and reflections, is arbitrary, will generate 12 of those 120, thus resulting in 12 possible base set permutations for 5 variables. Whenever any variable is a single step out of sequence, it will create this sort of fish-like topology, whereas if it was 2 steps out of sequence, you would get what I usually refer to as the sailor's hat. The only other 2 possibles are whenever they're in a 1-step sequence or a 2-step sequence, which would be the pentagram that we've referred to before. You can see how a lot of these can easily become different shapes based off of the movements that you apply to them, which makes it honestly pretty hard to avoid one of your goal sequences. Neural rules apply even if the spectator is allowed to freely select which variables go into place in the order they see fit. The only thing that changes is which of the N4 hourglasses requires a free move to be able to enter into the pentagon or pentagram sequence with the placement of your last variable, which will be controlled. So for example, the 3 and the 5 cannot be out of order no matter which placement they are around a circle, and the 2, 3, 5 will only be reversed with any single movement. Thus, they are in perfect order regardless of the state. With the 4th variable, you'll create one of the 2 hourglasses, or you'll create a square, which is them being in perfect chronological order. The step count relative to the variables available may change, but it is visually distinguishable as the exact same. So whenever that 5th variable were to be placed in this sequence, you can identify if the star would have been even possible. I can tell you just at a glance that if you can get the 4 into this position, you'll create a pentagram.